Today I am going to discuss on complex number system. We know that the square root of any real number systems is always non-negative. The real number systems like 2, 3, -7, -9, let's say 8 by 5, these are all real numbers. But when the number is like root under -7, then this is a negative real number which is under root. You can't write this particular, or you can't evaluate this particular square root of -7 in real number systems. Very simple example like 25. You can write 5 cross 5, that will be 5. But the number is like -25, then you can't write like -5 into -5, because minus minus when you multiply it becomes +5. So that's why you need to write like 5 cross 5. So there are one extra term, let's say -1 into 5 cross 5. So you can write -1 into 5 cross 5. So this is equal to 5, and that particular number which is called a imaginary number, and that will defined by the symbol I. I means imaginary number whose values take as root under of -1. So that's why you need to study the imaginary number systems. When the cases is like, if we consider the equation x square minus 1 is equal to 0, then what is the values of x? X is equal to plus minus 1. But the cases when we try to solve these kinds of equations where you will get x square equal to -1, x equal to root under of -1. In that case, you will get plus minus I. To solve that kind of equation, we need to use imaginary number. So imaginary number I is equal to root under of -1. So what do you mean by complex number then? A complex number z, which is defined by z, it is the sum of two real numbers, but one part is called, this is your real, x and y both are real. That particular part is called real part, and the whole part, if you consider, that particular part is called imaginary part. So this is your real part and this is your imaginary number. So then the whole number z is equal to x plus iy. This number are treated as complex number. Clear? So when you think about the number system theory, we know the first number is come, let's say natural number which starts from 1 to infinite. Then whole number, the whole number starts from 0, 1, 2, dot 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 till infinite. Then set of integers can be represented by the symbols, let's say I. The integers are defined as, let's say minus infinite, -2, -1, 0, 1, 2, dot 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 infinite. Then appear real number system, real number minus infinite to -2.5, -2, 1, -1, let's say -0.8, dot 0, 1, 2, and so on. So then comes to the world, in number system world, the complex number system, which is basically contain the two real number system, but whose one part is your real axis, and another part is imaginary axis. So suppose if I write z is equal to 3 plus 5y, then how to plot it? In real axis, I mean x axis, the point coordinate is 3, 1, 2, 3. So this is your 3, and imaginary axis is 5, 1, 2, 3, 4, 5. So the point is like 3, 5, and that particular plane is called imaginary plane, or it's called argon plane, or you can say jet plane, where we can plot a complex number. So a complex number defined as z is equal to x plus iy, which is the basically sum of two real number. So in our number systems, we can say that right now the complex number system is the largest number system where we can solve these kinds of equations where the root under any negative real number we can evaluate. Now, uh, what do uh, what do you mean by conjugate of a complex number? Suppose conjugate conjugate of a complex number. Suppose z is your complex number x plus iy. Then the conjugate of z is represented by z bar and that will be equals to x minus I. You just need to simple substitute in place of I minus I. In place of minus I, you need to put plus I. So, in geometrically, suppose you have organ plane and let's say here is your point x comma y, then its conjugate is defined by here. So this is your minus negative by y axis, this is your minus x axis, this is your plus x axis. So in minus y you get x minus iy. So suppose 3 4, that means a complex number system the defined as z plus 4i or 3 z is equal to 3 plus 4i, then its z bar is represented by 3 minus 4i, or in vice versa. If suppose this is your z, z is equal to 3 minus 4i, then this is your, then it will become z bar, z is equal to 3 plus 4i. But if you have some real number system, so let's say z is equal to, let's say 2, only 2 is there, then what is your z bar? Z bar is also 2. You know every real number is a complex number, but every complex number is not a real number. Very simple example, suppose here z is equal to 2. Now z is equal to 2 can be written as I into 0. We can write. So we can write in complex number form x plus I multiply y. So every real number, every real number is a complex number, but complex number is not real number, is not real number. Or let's say I just write here, but every complex number is not real number, is not real number. So very simple example, z is equal to 2 plus I multiply 0. We can express a real number in terms of complex number system like x plus iy. So here z bar, when you take this complex let's say conjugate, then it can be represent I into 0, that is also is equal to 2. So the conjugate of a real number is always a real number. So now, how to represent a complex number system into a polar coordinate system? So, we know that a Cartesian coordinate system, we have x-axis, we have y-axis, and let's say point B here having coordinate x comma y. Then that particular distance is your x, and that particular distance is your y. And this is your OA, and let's say that particular straight line makes an angle theta with the positive direction of x-axis. Then from this triangle OAB, so here Cartesian coordinate is x comma y, and polar coordinate is r comma theta. Then from this triangle OAB, cos theta is equals to, we can write OB by OA, base by hypotenuse. So x by r, this implies x is equal to r cos theta, and sin theta is equals to perpendicular by hypotenuse y by r. This implies y is equal to r sin theta. So this is a relation between Cartesian and polar coordinate system. Now, a complex number in Cartesian coordinate x plus iy, if we want to represent into a polar coordinate system, we can put x is equal to r cos theta plus I into r sin theta. So this is equal to r into cos theta plus I sin theta. So this is a representation of a complex number into a polar coordinate system. Now, what is the modulus of a complex number? Modulus, modulus of Z or complex number system. So, if we plot in organ plane or in Z plane a complex number, let's say suppose the coordinate of that particular point is xy, then the distance of that particular point from the origin it's called modulus of a complex number system. So, modulus, suppose z is equal to, for that particular point, we can represent the complex number in that particular organ plane x plus iy. Then modulus of z, defined as mod of z, is root under x square plus y square. So, modulus of z basically represent the distance from origin to that particular point. So, mod of z is equal to root under x square plus y square. Now, if we calculate the modulus of in polar coordinate system, you will get, so this is your x component and this is your y component in the complex number system. So, we can write r square cos square theta plus r square sin square theta. From here, you will get root under of r square, or this is equal to r. And z is equal to, in Cartesian coordinate system we already have root under x square plus y square equal to r. So x square plus y square is equal to r square, and this represents a circle. We know the equation of circle whose center at 0, 0 and having radius r is defined as root under defined as x square plus y square is equal to r square, where r is the radius of that particular circle. So mod z is equal to r. What it represents geometrically a circle whose center coordinate is 0, 0. Our next topic is amplitude of a complex number system. Amplitude of a complex number. So, if we consider an organ plane OX, OY, and let's say this is your IY, real axis, imaginary axis, A be any point x comma y, that point can be written as z is equal to x plus iy. Let's say this is your point P. Then OP, which makes an angle theta with the positive direction of x axis in anti-clockwise sense, is called the amplitude of that particular complex number. So, where theta is lies between minus pi to plus pi. So, then amplitude tan theta is equals to y by x, this is your y and this is your x, so you can write y by x, or theta is equal to tan inverse y by x. So, this is your amplitude or argument of a complex number system, and basically it's defined as m object, m object or arg argument object. So, this becomes theta is equal to tan inverse y by x. One thing is need to remember, when you calculate the amplitude of a complex number system, you first need to identify that the point z, it lies which quadrant system. I mean x and y. So like this is your plus first quadrant, this is your minus plus, this is your minus minus, and this is your plus minus quadrant system. So in which quadrant that particular point is lying? If it's like between minus pi to plus pi, then it's okay, its amplitude is given by like this in anti-clockwise sense. But if a complex number system is like that particular coordinate system or that particular coordinate system, then you need to move it through clockwise direction. And when you take in clockwise direction, let's say suppose here a complex number system P dash, in clockwise direction amplitude is always negative. So in anti-clockwise theta is always gives you positive, and clockwise says theta gives you negative value. So again I repeat, so what is amplitude? Amplitude of a complex number basically defined that OP, suppose P is your complex number, OP, it makes an angle theta with the positive direction of x-axis in anti-clockwise sense, and theta is always need to take between minus pi to plus pi. Then amplitude is of that particular complex number is given by theta is equal to tan inverse y by x. But suppose if a complex number lies on third or fourth coordinate system, then you need to take it clockwise rotation. And in clockwise, when you take clockwise rotation, it will be negative. I illustrate this by give some examples. Let's say suppose first we want to calculate the amplitude of the number, let's say root 3 plus I. So when you calculate the amplitude of that particular complex number, first you plot, but you need to identify that which coordinate system the point lies. So it's the first coordinate. So here root 3 plus both are plus. So point is like somewhere here root 3 1. Then its amplitude OA, which makes an angle theta with the positive direction of x-axis, is given by tan theta is equal to y by x. So this is your y coordinate, this is your x coordinate, and it lies on the first coordinate system, first quadrant. So tan theta is equal to 1 by root 3, and this is equal to tan 30 degree, or theta is equal to 30, or you can write in radian measurement pi by 6. So this is your, in that case, amplitude number of that particular complex number. Now, if we want to calculate the amplitude of this number, let's say z is equal to root 3 minus I, then if you plot the diagram x and y, so here plus and y is minus, so the point is like somewhere here root 3 comma minus 1. So here is your OA. So the amplitude, if you plot in clockwise rotation, you can see it lies on fourth quadrant system. So it always cross the minus pi plus pi limit. So we need to take in clockwise sense. And when you take the clockwise rotation, you need to take it, the value becomes is, amplitude become a negative number. So here, let's see, here tan theta is equal to y by x. What is your y? Minus 1. And what is your x? Root 3. So you can write minus of tan 30 degree, or you can write tan pi by 6, or let's say tan 30 degree. Tan 30 degree. So tan theta is equals to, since the point lies on fourth quadrant system, and you know this is your 0 degree, this is 90 degree, this is 170, 80, 270, and 360. So tan theta is equal to, you can write tan into 4 into 90, 360 minus 4 into 90 means 360 here, minus 30 degree. So 4 into 90 is an even number. So from the trigonometric concept, you know tan, when it is even number, the quadrant is not changes here. So tan becomes 10. So I just clarify here, tan 4 into 90 minus 30. That means 4 is even number. So when it is an even number, tan becomes 10 function. Here 30 degree, and it lies on which quadrant? Fourth quadrant. Since negative, So it's again revert back. So it lies on fourth quadrant system. And from the trigonometric concept, you know all sine, tan, cos. So here the function is tan, but it lies on fourth quadrant system. So this is your minus tan 30. So you can put it here minus tan 30. So this becomes tan 30 degree is equal to. So tan of, or here pi, I use pi by 2. In place of pi by 2, I just write in degree measurement because I write here degree. So 4 into 90. So it becomes 330 degree. So theta is becomes 330 degree, but it's not belongs to minus pi. It not belongs to minus pi to plus pi. It not belongs to minus pi to plus pi. That means minus 180 to plus 180. So what is our concept? We need to take the clockwise rotation. So from here to here, what is your theta? From here to here, you can write tan theta is equal to tan of minus 30 degree, or theta is equal to minus of 30 degree. In that case, this is your minus 30 degree, and in clockwise rotation, the whole angle becomes 330 degree. So what is your amplitude? Theta is equal to minus 30 degree, that is minus pi by 6, which is belongs to close interval minus pi to plus pi. So in that case, this is your amplitude for that particular complex number. So in that way, we can calculate the amplitude of a complex number.